Hey guys, Eric in the alley again. Today I still have Jim's Honda Accord in here. The starter should be here today for it, and I have to take the intake off to get to that. But what I was doing yesterday, and I ended up leaving the shop a mess. I mean, there's stuff everywhere. I was crimping shit. I solder and stuff. But I was trying to make a test, just a bench test, starter using the oscilloscope. See what I could see on the dead one that's coming out of this car. New one that's going in, and one I knew that worked, that the solenoid was bad, had to be hit a couple times to work. That's why it's out of the car. It hasn't given me no trouble on the bench, but that's why it's replaced. But the problem I was having is according to the wave I got, the pattern on the scope, it said it was drawing 400 amps. The last video I did on it, if you've seen it with the bad starter, it was saying that it was taking a lot of amperage too. So I started questioning the accuracy of the amp clamp, and I have nothing really to check it with other than a household one. It's an ideal one from Lowe's. It's about $100 multimeter amp clamp. It does have a DC current clamp. Yeah, and the waveform I got is, I'll show you in a second, but it was done with a jump box battery. I've hooked up to it. And after I seen it, the amperage is saying it's 400 amps in the vise. So it doesn't really sound like it's drawing 400 amps to me. But the voltage would coincide with it because the battery charger says the battery is 100% charged, but whenever it hits, it's taking it down to like 7 volts. So it would coincide with like taking 400 amps out of a fully charged battery, but that's a small battery. I'm not sure if that made a difference, but I did have a service battery out of a Caravan that still holds a charge. It says it's 100% charged, large battery. Going to run it with a full-size battery, see if the voltage drops that low. But somehow I want to come up with a bench test. But I have nothing to compare it with except that and a 60 amp low amp clamp that I might, see if I could push it up that high and see if it even gives me a reading, but I have nothing else to check it with. And that's why I even believe in having several meters or several scopes. It's to check you always have to check your equipment. And if this is wrong, what's the point of measuring anything except looking at a cool, pattern on the screen, which is its own thing. But, we want to get an accurate measurement. That's what it's all about. So I want to see how accurate that is. Might have to, eventually buy another one just to back it up. But we'll get into that later. But let me show you what I got. So that's the battery on the Harbor Freight charger. It says it's 100%. So I had everything. Got solder splatter and a whole mess over here too. But this is what I had. I figured nice and simple. Battery. I did have 2 leads going there to get the voltage measurements. Just running the cable up to the starter and the vise. I got the power probe going to the starter terminal so we could power it. And I got a really nice waveform. I was happy at first. I mean, as soon as you see the image, you're like, yeah, you got a good capture, and almost immediately you start looking for detail and stuff. But I actually, played around with it for a little bit. This is no filters. Before I just realized, what I was seeing. Let me separate them a little bit. I don't know if the eyeball will do that for me. No. But even the guesstimate, 400 amps. But look at the battery. It's going down to 6 volt. It didn't sound like that, but it would be a really nice test. And I mean, there's no point in getting into the details on this one. We'll get it on the new one we capture, but with or without filters, got some really good resolution. I was pretty happy with it, actually. Like, when you first see it and you're like, wow, that's a pretty decent waveform, but Yeah, the numbers didn't just look right. To my ears, it didn't sound like it was 400 amps. All right, let me get it set up with the car battery, put some of this junk away, and before we put the starter in this car, we're going to have that starter, the new starter, and this Taurus starter to get some kind of waveform, develop some kind of test. We're going to see known good, hopefully, with the Mitsubishi starter for a Honda. But that's going to be our known good that we're going to go off of if it works. We should be able to hear with our ears if it works. There should be some kind of data sheet with the starter. We know what the known bad looks like. Now I'd like to try to power that one on a vise, see what the bad one looks like on a vise, because that was turning all the cylinders of the engine. If this is going to be a no-load test, I want to have a no-load test with a known bad too. This one, this Taurus, this would I would have said somewhere in between a known bad and a known good, but the waveform we got was pretty good. I mean, pretty interesting. Sometimes just a simple starter we overlook this. This is an easy test to do, even if you don't have a car in the winter in your basement. If you don't have a car that you're working on, you know, you could run these tests on your scope. This is how you get used to the scope. And if I didn't mention that this is the DC amp clamp that I was comparing it to, this said it was drawing 140 some amps. Now, if you want to see something a little bit disheartening, whenever I was looking into whether I could use that or not to get a good measurement, or if it's giving me an average. Because if you remember from a lot, you know, Danner's video, he stresses it a lot, that these are only giving you the average on voltage. But on amperage with a min and a max scale, I mean, it should be more accurate than just an average of amps. But if it is an average of amps, you know, it could be the 400. But, you know, I don't think so. It was saying 140 some. So the only other thing I have to compare it to is a 60 amp. I mean, I might have to just for the sake of finding it out. When I asked Google, it told me no, an oscilloscope amp clamp is not typically as accurate as a multimeter or a clamp meter. And the clamp meters are for, you know, they're talking about multimeter clamp meters. But we shall see. It doesn't sound right. Alright guys, this is the basic setup. Got the voltage taps going to the scope on channel 1. I have the amp clamp going to, that'd be on the positive cable. It's going to the back of the solenoid. I got the power probe connected to the starter switch, the ignition, and then I have the power probe in between, so whenever I hit this button, it's been working for me every time too. And I know this one is out of my dad's Taurus. You know, last time I left him down Dollar General, I gave it a whack and it started. But at any rate, it's a good test subject and something to have to compare in between, in the middle, between the new and a totally shot one. So what I'm going to do, and I just got hscope hooked up on the side. I did another 0 level calibration on both channels. And what I'm going to do is just get it ready. It's on 150. I'm going to bump it up 300 in the blue. Okay. On 4 milliseconds, we don't need 32. On channel 1, 16 volt will be fine. On channel 2, it'll go down the whole way to 180 millivolts. Let's try that, because that would be 980 amps. That would be the highest part of its scale. Now what I'm going to do is just hit record. And I want to make sure the amp clamp is as close to 0 as I could. It's a -7 now. And it's going the other way. That's as far towards that way as I could get it. Here we're going back and forth between positive and negative a little bit, so we're pretty close to 0. What I'm going to do is start it, and then just hit the run. And stop it, make sure I got something somewhere. Okay, there we go. Now I'm going to switch over to screen recorder just so we could check our readings. Okay guys, let's take a little bit better look at it. See what we could see without a filter. Try to look at the beginning here. You see it missed a couple times, so like 2 little ones that made a quick recovery on them. We should see the same in the voltage. We should see these little dropouts. That's what I've been looking for. Like, you know, just, I'm not really looking for, but, you know, finding a way to look and see what we see. And on the starter, this is going to be pretty common. Whenever it misses, there's 2 misses in it, and you could hear this is freewheeling, and it still missed twice. Not a bad miss. You could hear with your ears what that means. I mean, what that sounds like. It's not, nothing by the sound would tell you that's a bad starter. It sounds pretty good, but one thing I was a little bit happier about anyway is the amperage did come down some after the calibration. But we're still we'll say close to 240 amps. Seems a little bit more than it should be. I mean, especially the way we hear it sounding. But what I wanted to do next, and we could see on the waveform line, you could clean this up as much as you want. I was playing around with the other one last night, and like the voltage, like whenever we see these in a car, whenever we turn the key and we see this little click in here, I imagine the first one's the power probe closing right there, because we're hooked up live in the circuit with the battery. So whenever I send power to it, one switch closes in the power probe itself. And I think that's what we're seeing in here. And then I think all this is actually in the solenoid. And then whenever it switches, we could see the miss, but the little dropouts, I mean, they're not huge compared to what the one in the car looks like. It's going to be fun to spin that freewheeling device and just see how, and have something to compare it to. By that time, we're going to have 2 to compare it to. We're going to have this one, and we're going to have the new one. So we're going to see if there's any, you know, major differences here. But whatever way you wanted to look at this, and I'll keep that there just in case the filters, I always keep it there to make sure it doesn't change the amplitude of, you know, your signal, because if you don't want to clean something up for the sake of just cleaning it up. If it drops the amplitude, leave it dirty. So there's with a low pass on, and we didn't drop. If we did, it's, you know, insignificant, just to get a better view of it and how clean it does. If we zoom in, the filter might have taken a little off, or as the image is small, I might have been off a little bit. You know, but still, we're talking about 240 amps either way. And then actually, after the thing's actually running, we drop down to, that's another thing I was looking into, like, you know, can we get, what's the way to hook an RPM up to this motor? I mean, what do we need? I have, for the Modus, I do have an RPM clamp, but it does have a different end. It has more almost like a VGA end. Well, yeah, that's pretty good for looking at, that should be looking for something major dropping out. We have a pretty good waveform on there. I mean, it's all this ripple. That's what we got to try to see and try to look at. I mean, this is all normal. We have to get used to what normal looks like. Because if you're just looking at a signal, you're going to see a lot of differences in this. I mean, we see how it goes up and down, but it's not going major amounts. It's still forming a nice smooth wave. If you had dropouts at all look like this, you know, I mean, you might be a little bit more concerned, but we could see this waves. It's the same repeating pattern. The way it drops down, everything, I mean, we have a little more detail than you actually need for this test, but what I'd like to do is actually run it and put all the resolution onto the amperage channel on the channel 2 here. And just see what the difference is. That's what I mean. This is all, you know, experimental, just looking for these dropouts. It's almost like we're looking at compression humps. We're looking for one that's sticking out. You know, if we seen this constantly repeating, which we kind of do, but it's not dropping far enough that, you know, if you got this kind of waveform out of a car and the starter's still in the car, keep it in the car. I mean, I wouldn't replace this unless, like, you know, you had solenoid troubles like that did. Nothing's repeating really bad. And that's just running wide open there. Move it down to where I had it running a little bit. Then we'll just take a measurement on there. I think on the specs sheet, whenever you do get the starter, so it should be running at like 60 amps, 68.51. We're a little bit low there, but if we were going for the middle of it, we're running at about 53 amps. Okay. So that seems kind of, I mean, a decent amount, but even running, you'd think after that motor was moving 50 was a little bit excessive. I mean, 50 amps is a lot, especially to keep a motor running that started that easy. But next, what I'd like to do, well, I would like to get this in better resolution just to take a look at it. Even, I mean, this is that's good enough resolution, but like I said, we're just playing around. But what I'm also going to do is use the multimeter amp clamp and see what it compares at first. All right, same setup, only with the addition of the multimeter amp clamp. I'm going to take it to DC amps. I'm going to take the range, make sure we got 3 digits, zero it out. I'm going to just sit back, hit the button on the power probe. Oh, you know what? I didn't put it on max. Yeah, I just put it on the min-max so we get the maximum. $153 amps. So we have 153 and close to 240 according to the oscilloscope. Now that's the question of the day. To my ears, it sounds more like this is right. And on the actual scope, I mean, the battery on the other one, that's why I took it and put the car battery on it. The jump starting batteries were going down to like 6 volts. So you know, you could figure 400 volts Might have been a big enough drop to knock them little batteries silly. Because, you know, if you ever use some Harbor Freight ones to start a car, you get one start. And on the bench, it's dropping down 962. And I've ran it a bit, so, you know, that's not hitting like, you know, like it's definitely not hitting like the 400 amps. But what we have down here is just, it doesn't, like even getting close to that peak. Almost in the 500 there, but I'm off. You're best to do this zoomed way in, but no, before I was actually looking at the voltage side at the 289. We're on the amperage side. This is saying it's taking 562. So I'm pretty sure my amp clamp's way out of whack. So that might be needing replacement very soon. I have nothing else to compare it to other than this right now. I do have a low amp clamp. It's a 60 amp. I'm not sure if, you know, it would be way over scale. It would be twice out of its range. I don't think we could hurt it though. Well, let's find out. One more time on, I moved it up to 600, the sample rate. I moved it up to 600 kilosamples a second. So when I zoom in, you can see it caught on the first latch that time. That line's almost straight up. And I do have a low pass filter on it now. The line's straighter up without the filter. But not, you know, not much. It's still pretty straight up. But if you look at that, I mean, that's pretty good resolution for no filter at all. The amperage are usually pretty safe with the low pass. It doesn't affect its amplitude as much as the voltage seems to. And that's twice the resolution of the single channel. We could see we do get some very fine detail. And I'm not sure you'd be looking into it this much. You'd be looking for a lot of these peaks to just, you know, not be there. There'd be a big gap somewhere. Or something not consistent like this way. These little dropouts, it's, you know, it might indicate where, I don't know. But it wouldn't be enough. No matter what you're looking at, this wouldn't be enough to make a replacement based on, but it's pretty cool. We could zoom in. Now, the one that's in the car, it's going to look a lot different than this. This is kind of what we'd like to see. Now, when we look at that one, it's a lot different. But it'd be nice to have a simple bench test for a starter, and that's what you start out to do. You could see us over here. This is almost up at the 540 amp mark. And I just don't, you know, 540 amp, I doubt that here would hold it. But one more thing I want to do with that amp clamp, you know, we're getting a difference in both of them. I was going to run it without the solenoid, just jump the power to the motor, but that still doesn't explain our difference. You know, it's definitely a good image, but I'm not sure the scale's right. If there's a way to redo the scale, I'm just going into the millivolts because it's 1 millivolt per amp. So whenever it's running here, we're staying at like around 60 amps, which for a running motor is a lot. Now, it's not excessive. But once the motor, you know, overcomes movement, it usually drops down. 50 amps is kind of a lot to keep it running, but these are starters. I mean, I've never put an oscilloscope on a car and just, you know, cranked it, you know, wide open and taken a look at it. But this is kind of cool to get it out of the car. you know, this is what it looks like on a bench. You know, what's going on with the compression? How's it affecting this? But this is the base I want to see, and I want to see it on my own scopes like this, because everybody looks at things different. It's like the way you set your equalizer in your car, you know, where you put your apps on your phone. It's like you're going to like looking at this different. I mean, I'm getting older, my eyes are getting worse, so the most detail I can get's the best, the most zoom. You know, you're going to get the way you like to do it, and you know that's that. You know, there's different ways of, you know, looking at things. I know this is only a starter, but you know, the first way I like looking at things is like this, you know, zoomed out. So if you see something huge, you could just zoom into it. And the pinch to zoom, it's real easy. I mean, you can manipulate your waveform. You can do, you know, pretty easy. The worst thing about it, honestly, is sometimes the screen just moves. There's probably a way to lock it, but I'd be touching the screen and then the waveform starts moving like you'd want to if you were looking for something. But if you're measuring it, sometimes I move it. There might be an anchor on it, but, you know, it doesn't bother me. Well, the next thing I want to do then, being like, you know, jumping straight to the starter, I thought maybe if this thing truly was drawing 500 amps, some of it would have to be in the solenoid, like extremely high resistance in there, but that still wouldn't explain the difference. I mean, what is the difference between the multimeter amp clamp and this clamp? And I kind of wish it was the other way around, that the multimeter was giving me the worst reading, the most questionable reading, because I use this amp clamp a lot. And then the last video I did, doing it in this car with this amp clamp, it was drawing, it looked like 500 and some amps turning the engine. Now we're drawing 500 amps, not in the amp car. So if it's my clamp, I definitely got to replace my clamp, and that's the way it's looking. But it's developing the test, so there's no waste of time. There's no waste of anything. I hope to set up a quick test, but here I am making pieces and, you know, you're questioning my equipment. But that's what you got to do. If your equipment isn't reading right, you know, what are you doing? We're just looking at pretty squiggles on the screen. But all right, now that part's out, I'm not sure if I want to put that low amp clamp on there, but, you know, if it's the 150, maybe she'll take it, but we're going to find out, yeah, for the sake of exploration. All right, guys, enter player 3. This is an AES Wave, the same one as the high amp clamp. This is the low amp clamp. Its maximum voltage is 60 amps, and that's going at 10 millivolt equals 1 amp. The big one was 1 millivolt equals 1 amp. This one, it's going to take 10, so all they're going to be doing is adding a 0 with this one. It has a different kind of calibration. You kind of touch this button. The other one's a wheel, like this. And you turn the wheel to get 0. This one, you kind of bobble this, and you got to make sure this don't get stuck, because they do sometimes. Make sure the battery's good. I'm going to put it on 60 amp, and we're going to just hope that this thing isn't drawing 500. Now, I mean, what damage can you do? Because this is like, you know, it's inductive. It's picking up around the wire, so you're not really running high voltage through it. And really, well, the way I look at it, these are both the same brand. If that one's that far off of calibration, I don't want this one either. So we're going to run them and see if they line up. Low amp clamp hooked up. I'm still going to keep it on ×1 down here. We'll take the filter off for the actual capture. And we'll see what this one says. See if we could get some kind of common ground. Okay, let's stop that. You go back. We're seeing the same image. see we cut off the top of the scale here. Okay, yeah, it's because we're up to 980 millivolt here. Oh, will 3.2 be enough? I believe so. That's a good, see if we get that spike in there. Okay, and go back and look. Might have been peeking that little scope on it. There we go, we got a peak on there. Well, what's the difference here? $211. $211 amps, and that's what we're talking. We're losing accuracy over 60 for sure. We're seeing the same pattern there. And yeah, see, here's where its range is a lot better. That's where you're going to see a lot better signal. But it's back here to where we're really over pushing it. But we're definitely, with this one saying it's taking 50 amps more than the other one, which is a lot closer. But really, which one is our accurate one? Was this because it's so far over 60? Are we really around 150? I don't know. I wish I had a good way of testing this, but this don't look right up here, especially when you're looking for a peak. Our amp clamp's definitely out of its range, but didn't blow up. I don't see no smoke anywhere. All right, so it's kind of, I don't know which way to take it. Is it just inaccurate that far off of what the multimeter said, or was this on its way up to 500? It don't really look like that because it comes back down into its range pretty quick. But I'm sure this number isn't accurate. Looks closer to the 150 though than the 500. All right. So it's definitely looking like I need a new amp, guys. Oh well, I got a new scope coming. Maybe I'll have a new amp clamp coming with it. And to double check everything, I just used the amp clamp, running the U-scope on one channel. The max voltage would be 568 amps. That seems to coincide with what it did on with hscope on the tablet. But it's always good to have something to double check your equipment, because that's what you're using to check things. So I mean, you have to have a way of falling back, whether it's a voltmeter or whether it's another scope like that. You're better off just taking that measurement now, making sure that everything's pointing towards, you know, the actual amp clamp. All right, this turned into pretty much diagnosing your diagnostic equipment, which, you know, wasn't the intent, but you have to, because we do need some accurate, you know, equipment. That's what we're doing, is we're taking measurements. But I did, there's highs and there's lows, there's positives and there's negatives. I mean, on the positive note, I have a good, still got the opportunity to check these 3 starters. My amp clamp's way off. I mean, what would you guys do? What's your input? I mean, I look forward to seeing what you do. Would you call it amp clamp bad and throw it? Has anybody taken one apart? Is there a trim wheel or anything that we could calibrate it manually? But it's way out. You've seen it on both scopes, and you've seen the handheld multimeter, what it was reading. So it's all pointing towards that, you know, that amp clamp. I got that off AES Wave a couple years ago whenever I got the U-scope. Now, the low amp clamp came in a sealed box and the battery was not in it. The high amp clamp came in a greasy box. There were some fingerprints on it. You could tell it was open, taped shut. The battery was in it, and the battery indicator for a weak battery was already on. So I don't know if it's one somebody returned, they sent it back, you know, and they resold it to me, and I didn't know any better. But now I know how to check for the accuracy of equipment. I could have sent that back in a return window, but hey, you know, it's water under the bridge now. Now I'm going to look for a high and low amp clamp, because after you get done like that by somebody, you know, I don't trust their other one either now. So, you know, I'm going to be on the lookout for some amp clamps, but I look forward to your input. Like, you know, is it a pretty good test? Is there anything else I should be testing? I mean, is there a way to put a load on this starter? I don't believe so without engaging that gear, but it's a pretty quick test to set up the starter. Pretty happy I got that far. I got the cables made. You know, I know what some waveforms look like. It's just their measurements not right, which made, if you watch my last video on this Honda, that starter wasn't drawing that much. Is my amp clamps bad? But sometimes that's how it goes. All right, guys, thanks for watching. I look forward to hearing what you got to say. Adios.